Okay, so we're going to do factoring with complex numbers. So to do that, we need to kind of look back at something we've talked about in the past called the difference of squares. So I'm going to go back to like the way beginning of it so we can see how it connects to what we're doing in this lesson. So we have x squared minus 81. In reality, that is truly x squared plus 0x minus 81. And it's a trinomial, which means I can use a box to factor it, where this is the a, the b, and the c. And so x squared would go here, negative 81 goes here, 0x is here, and we multiply a and c together to get negative 81x squared. And this is where we're trying to figure out what two numbers would multiply to give us the negative 81x squared, but if you added or subtracted the two numbers, you would get 0x. So 9x times negative 9x makes negative 81x squared, and 9x take away 9x makes 0x. So we have the correct combination. So to get the factors, x times x would make x squared, x times 9 makes 9x, and x times negative 9 makes negative 9x. And we can see that 9 times negative 9 makes the negative 81. So our factors are x plus 9, x minus 9. But once again, this was a difference of squares up here, which means we've learned that there's a shortcut where we ask the question, what two identical numbers would multiply to give me x squared? X and x. What two identical numbers multiply to give me 81? 9 and 9. And we can know that the two signs should be opposite of each other. And since we know that happens, we take the shortcut, where we simply ask the question over here, what two identical numbers multiply to give me 4x squared? 2x. 2x times 2x is 4x squared. And we do the same thing with the 49. What two identical numbers multiply to give us 49? 7. Therefore, we have 2x plus 7, 2x minus 7. Once again, this is called the difference of squares, because these are perfect squares up here. All right, so keep this in the back of your head. Moving on to multiplying complex numbers. Now, we've done this before, but something interesting is going to happen that we're going to look at when we do it with these, where we have x plus I times x minus I. So I'm going to go ahead and remind you that when they're in the parentheses like that, this is what we call factors. These are called factors. Just like we saw in the last slide, our answers are factors. So here, I'm going to make a box. But since these are factors, they go on the outside. Okay, and so now I'm just going to multiply. So x times x makes x squared. X times negative I is negative ix. I times x is ix. And I times negative I is negative I squared. Well, if you have ix and then you take ix away, well, you make 0. So those aren't really there anymore. What we're left with is x squared minus I squared. Now, as we talked about last week, I squared is actually the number negative 1. So what we really have here is x squared minus negative 1. Well, two negatives make a positive, so we really have x squared plus 1. Okay, keep that in the back of your head. Let's look at another one. There's something going on here that you may start to notice. Once again, these are called factors, and so I'm putting them on the outside of the box. I'm going to multiply to make the inside, so x times x makes x squared. X times negative 5i is negative 5ix. And 5i times x is 5ix. And 5i times negative 5i is negative 25i squared. All right, so once again, if you have 5ix and then you take away the same amount, you have no more 5ix. So we're down to just x squared minus 25i squared. Well, once again, I squared means negative 1. So we really have is x squared minus 25 times negative 1, which means that's really x squared minus negative 25. Two negatives make a positive, so this is really x squared plus 25. Well, we can see that from x squared plus 1, these would be the factors. Well, they look kind of similar. They have opposite signs. Maybe I can treat this like a difference of squares. So I ask the question, are there two identical variables that multiply to give me x squared? Yeah, x. Are there two identical numbers that multiply to give me 1? Yes, 1, which is the invisible number in front of the I. Let's look over here. We have x squared. Are there two identical numbers that multiply to be x squared? Yeah, x. Are there two identical numbers that multiply to be 25? Yeah, 5. But just notice how the only difference is that they have i's this time. We have an I here, an I here. But what causes that I? Pretty simple. It's the plus sign in the middle. It's simply the plus sign. And since there's going to be a plus sign in the middle instead of a minus, the only thing that changes is that you bring in an I for your second term. You can still use the same shortcut as before. So if I had x squared plus 81, well, I asked the question, what two identical variables multiply to give me x squared? X. What two identical variables what two identical numbers multiply to give me 81? 9. But since there's a plus sign, that needs an I. So the factors would look like this. And that's the sum of squares. Once again, let's look at some examples here. So if we have x squared plus 36, I don't need to figure out this with a box. I can take the shortcut. Two identical variables that multiply to be x squared, that's x. Two identical variables that multiply to be, two identical numbers that multiply to be 36, that's 6. But since there's a plus sign, it needs an I. So my factors are simply x plus 6i, x minus 6i. Same thing happens here. Two identical numbers that multiply to give me 4x squared, 2x. Two identical numbers that multiply to give me 49, 7. But since there's a plus sign, it needs an I. So I have 2x plus 7i, 2x minus 7i. So if I had 4x squared minus 49, I'm still kind of going through the same process. What two identical numbers multiply to give me 4x squared, 2x? Two identical numbers that multiply to give me 49 is 7. But since there's a minus sign, there's no I. So the factors are simply 2x plus 7 and then 2x minus 7. You kind of see how the difference is? It's all about that plus sign. So now we've kind of talked about a few different forms. We've talked about a difference of squares, where each term was a perfect square trinomial, which pretty much gave us the form of a plus b, a minus b. We just talked about the sum of squares, where the two terms are perfect squares, but there's a plus sign in the middle. And that gives us the form a plus bi, a minus bi. And then earlier this week, we saw the sum of cubes. And since it has an exponent of 3, we have an actual equation that helps us out. Plus, minus, plus, ab, a squared, ab, b squared. And then you have the difference of cubes, where we have the a, where we have the same sign, opposite sign, always positive, a, b, a squared, ab, b squared. And these are the different factors, these are the different expressions where we can take a shortcut to factoring, where it's mostly just mental math. And so these are the ones you just have to make sure you recognize and know when to take those shortcuts. All right, so let's take a look at these real quick. Once again, it lets us know that these are a sum or difference of squares. But if I think here, I need two identical numbers that multiply to give me 8. There isn't any. 2 times 2 is 4, 3 times 3 is 9. We already passed 8. There isn't one, which gives me the clue that there's probably a greatest common factor. Now, 8 and 50 are even numbers. Therefore, they probably have a GCF of 2. So if I take a 2 out, that means 4x to the 4th times the 2 would get me the 8x to the 4th. And 2 times negative 25 would get the negative 50. So now I can see if I have a difference of squares. Are there two identical numbers that multiply to be 4x to the 4th? Yes. It's 2x squared. Are there two identical numbers that multiply to give me 25? Yeah, it's 5. Since there's a minus, I don't have to worry about the i's. It's simply going to be the GCF that's in front, and then 2x squared plus 5, and 2x squared minus 5. In our next one, we have a 25 and a 36. They definitely don't have a greatest common factor. I can simply ask the question, what two identical numbers multiply to give me 25x to the 4th? 5x squared. Two identical numbers that multiply to be 36? 6. But since there's a plus sign, it needs the I. So our factors are simply 5x squared plus 6i, 5x squared minus 6i. Great. Almost done. We're just going to look at this first one here. So it's a trinomial. When it's a trinomial, there's only 3 terms. I want to go ahead and make a box, and I'm going to need to go ahead and find some combinations for this one. So once again, this is going to be the A term, the B term, and the C term. So A, C, A times C, B. All right, and we're going to have x to the 4th, 27. Here will be 12x squared. Multiply the A and the C together to get 27x to the 4th. So we need to figure out two numbers that multiply to be 27x to the 4th, but those same two numbers will add to be our B value, which is 12x squared. The combination that's going to work is going to be 9x squared and 3x squared. 9 times 3 is 27. X squared times x squared is x to the 4th. 9x squared plus 3x squared would add to give us 12x squared. So we're just going to put those in here. All right, so we got to get the outsides to find those factors, which is what the directions are asking us to do. So I know x squared times x squared is x to the 4th. X squared times 3 makes 3x squared. X squared times 9 makes 9x squared. And 9 times 3 makes 27, so I know I've done this right. So now I have the factors x squared plus 9, x squared plus 3. But now you're going to start coming across problems where sometimes there's a sum or difference of squares as part of the answer, which means you can factor even further. So we have to check. We have x squared here. So I think to myself, are there two numbers that are identical that give me x squared? Yeah. X times x is x squared. Are there two identical numbers that multiply to be 9? Yes, 3. So this first one's a difference of squares. So that's going to break down and look like this. X plus 3, x minus 3. Oh, don't forget, we had a plus sign. That means I need i's right here for those because of that plus sign. I look to the next blue factor. Are there two identical variables that multiply to the x squared? Yes. Are there two identical numbers that multiply to be 3? No. So that just becomes part of our answer, x squared plus 3. And now we have our solution. All right, this is going to be our last problem. We have a 4-term polynomial, so I'm going to make my box. And with the nice thing about 4-term polynomials, you just put them all into the box in the order of a z. So here we're going to have x to the 3rd, x squared, 16x, 16. Once again, whatever variable is here is the one that shows up over there. Whatever variable is here is the one that ends up top. So x squared times x makes x to the 3rd. That's looking good. X squared times 1 will make x squared. x times 16 makes 16x, and 16 times 1 makes 16. So I know I got the factors right. So x squared plus 16, x plus 1. All right, once again, we need to check to see if there's any sum or difference of squares, because it wants us to factor completely. So are there two identical variables that multiply to be x squared? Yeah, x. Are there two identical numbers that multiply to be 16? Yes. So now we're going to have x plus 4, x minus 4. One, don't forget, we got a plus sign. There should be i's there. Our next factor, we have just a single x. So there aren't two numbers or two variables that multiply to give you x. Therefore, it's just part of our answer. All right, on eCampus, you have the classwork assignment where this video was embedded. That's out of your practice book. So you could do it in your practice book, or I will also upload the PDF for you so you could do it there if you do not have your book with you.